Okay, so let's go do this. This is a tree, so either it rains or it's fine. The probability that it rains is 0.2, so therefore the probability it rains is 0.8. And either will rain or be fine. It either will rain or it will be fine. It says if it rains today, the probability of rain tomorrow will be 0.15, so this would be 0.85. And if it's fine today, the probability that it'll be fine tomorrow will be 0.9 and 0.1. Okay, so I'm going to go find the probabilities. Okay, so I found the probability, so let's go make the probability model. Now, I don't have room here, so, and it's for rain, so I'm going to do rain, and the probability that x is equal to x. So either we will have no days of rain, 1 day of rain, or 2 days of rain. Okay, so no days of rain is fine and fine, which is 0.72. 2 days of rain is rain and rain, which is 0.03. And so one day of rain is rain and fine, or fine and rain, which is these two, which is 0.15. So there's the probability model. All that work just for A. Okay, so let's do the expected value. So the expected value of rain is going to be 0 times 0.72 plus 1 times 0.15 plus 2 times 0.03. And so what do I get? 0.21? Okay, that is wrong. I apologize. So let's do the variance of x, which is going to be 0 minus 0.21 squared times 0.72 plus 1 minus 0.21 squared times 0.15 plus 2 minus 0.21 squared times 0.03. Okay, so I need to go find out what this is. Okay, so I get that the standard deviation of x is equal to the square root of the variance of x, which is equal to 0.51. I thought it was 0.31. Anyway, so I got 0.51. I guess I'll have to do that one tomorrow in class. All right? Okay, so they want to know the mean and standard deviation he might spend on 2 consecutive days. So I think you realize this is 2 different days. So this is the expected value of x1 plus x2, which is the expected value of x1 plus the expected value of x2, which is 13.50 plus 13.50, which is $27. Okay, so let's go find the variance of x1 plus x2 is equal to the variance of x1 plus the variance of x2, which is 7 squared plus 7 squared, which is 49 times 2, which is 98. So the standard deviation of x is equal to the square root of the variance of x, which is equal to 9.90. And we're talking about money here, right? Okay, now it says estimate the weekly food cost and the standard deviation. So that's going to be now the weekly food cost. All right, and so the weekly food cost. Okay, so those are different food costs. So that is going to be the expected value of x1 plus x2 plus dot 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 x to the 7th, which is equal to the expected value of x1 plus the expected value of x2 plus dot 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 plus the expected value of x to the 7th, which is 13.50 plus 13.50 plus dot 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 plus 13.50, which is what? 13.50 times 7. So I get $94.50. Okay. Now let's go do standard deviation. So I'm going to erase this here. And I'm going to change my colors. So the variance of x1 plus x2 plus dot 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 plus x to the 7th is equal to the variance of x1 plus the variance of x2 plus dot 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 plus the variance of x to the 7th. So this is equal to 49 plus dot 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 plus 49, which ends up being what, 7 times 49. Okay, so I get 343. So the standard deviation of x1 plus x2 plus dot 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 plus x to the 7th is equal to the square root of the variance. So the square root of that is $18.52. $18.52. Do you think it's likely that he'll spend less than $50 a week? So my mean $94.50 with a standard deviation of 18.52. 50 jeepers, I doubt that. Look at that. So my z is going to be 50 minus 94.5 divided by 18.52. 50 minus 94.5 divided by 18.52, and I get negative 2.40. So the probability of x1 plus x2 plus dot 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 plus x to the 7th is less than 50 is equal to the probability that z is going to be less than negative 2.40 is equal to, okay, so I'm going to go to my z-score chart, and I get 0.0081. So what can I say? That there is a 0.81% chance that they spend less than $50 a week for what? Meals? Okay, if you still have any help, come in for tutoring.